Hi dear students. So in the last class we have discussed about the kinematic equations regarding the uniform motion. Now by using those kinematic equations, some application level questions are given in your textbook in example. The first two examples we will discuss today. So the first one, example 3.3, obtain the equations of motion for constant acceleration using method of calculus. Method of calculus in the sense that differentiation and integration. So in another way, another method, so by using the method of calculus, okay, we are going to derive those kinematic equations one more time. So this is also one of the important questions, but as you are not much familiar with the differentiation and integration, just listen carefully, okay. So as we know, the instantaneous acceleration A can be obtained by using the equation A is equal to dv by dt. A is equal to dv by dt. So by rearranging that equation, we can rewrite that equation as dv is equal to A into dt. Okay, dv is equal to A into dt. Now we are integrating both sides. Okay, we are going to integrate both sides. Actually, the integration is the opposite of differentiation. Okay, integration is exactly the opposite of differentiation. Differentiation in the sense we are just fractionalizing we are just taking only a few fraction of that entire thing or entire value, that is known as the differentiation. But integration, maybe if you are having a fraction of value, with the help of that fractional value you are going to find out the entire value, that is the integration. So here the fractional values you are having, one is dv and another one is dt, a very small value of the entire velocity, that is dv, and a small time representing the entire time, that is dt. So if you are integrating the dv, you can get the v value, you will get the v, and if you are means the entire velocity, and if you are integrating the dt, you can obtain the entire time. Now we have to, but in this solution, you know that on the integration the limits are applied. Limits are applied in the sense if the integration, the sign of integration is this one, if on the bottom and upper portion the values are given, that means the limit is applied. Okay, so we have to consider the limit also. So here in this case, the v velocity is having the limit v0 to v. So that means as a picture representing, if I am representing as a picture, the dv means a small portion. Okay, this is dv, a small portion of the velocity. v0 the initial point, v the final point. So you are going to find out that entire velocity, okay, with the help of the fractional value dv within the limit of v0 and v. That is the meaning of integration simply. I think now you understood it. So the limits are v0 and v. So we have to apply the integration. So here in this case, here the limits are, a is actually the constant. Okay, a is a constant and the limit is, देखो, t0 to or 0 to t. Initial time is considered as 0, final time is dt, t, and the fractional time is given as dt. Okay, now we are integrating that equation both side. देखो, here the dv, when you are integrating the dv, okay, so you will obtain the v. Okay, v in the limit of v and v0 will be is equal to a is a constant, a will remain as it is, a into t in the limit of t and t 0. Okay, now you have to write this one as, that is v in the limit of v and v0, a, and the integration, we have done the integration, dt became t and dv become v. Okay, dv became v and dt became t. Now we have to apply, as you are having the limit, so you have to apply the limit for the integrated values also. Then this will become the, in the square bracket v, the limit of v minus v0 will become v and v0, in between v and v0 will become v minus v0. Okay, that we are applying the values v here, v v0 v is equal to a into t t0 t. Okay, so you have to apply the limit. Then first value you are applying here. Okay, so v minus second value, that is v0 minus v0. Okay, that are the two values of the velocity. So v minus v0 you are applying, and which will be is equal to the same here, a into t minus, here the t0 we have taken as in the limit as 0 only. Okay, here it is 0 only, so a into 0 will come, a into 0 will be 0, so we don't want to consider that one. So v minus v0 is equal to at, so we can say v will be is equal to v0 plus a into t. Okay, v is equal to v0 plus a into t. So you obtained the first kinematic equation of the uniform motion with a constant acceleration, isn't it? So v is equal to v0 plus at, that was the equation with the help of the integration or the calculus, you have found that value. Now we have to derive the second equation. For that you should consider, that is the, in the first one you have considered that a is equal to dv by dt, that is the instantaneous acceleration you have considered. Now for the second one you have to consider the v is equal to dx by dt, that is the instantaneous velocity. Okay, and then as we have done in the earlier case, the same thing, as v is equal to dx by dt, dx will be is equal to v into dt. Okay, where you have to apply the limits again, integrating sides, x as x0 to x, here it is 0 to t, 0 to t. Now So I think this much it is clear. So we have applied the limit and we are integrating. So x0 is the initial point, x0 is the initial point, x is the final point, 0 is the initial time, t is the final time. Dx is a fraction of the position, a fraction of displacement, a small displacement dx. The time required for that displacement is dt, and the velocity with which that body is moving is v. Okay, so these much things are these are the things that you are having. So now you are integrating that equation. So what will come? Let's see. Okay, but instead of this v, okay, here instead of this v, you are applying the value v0 plus at. Okay, instead of this v, here one v is there. Instead of that, we are applying the value v is equal to v0 plus at. So you are substituting that value over here. Then the equation will become integral 0 to t v0 plus at into dt. So in the left hand side, x dx will become x, integral dx will become x. So x in the limit x0 to x will be is equal to v0 plus at, v0 plus at into dt. So it will be, you can just write that one as integration of 0 to 2 v0 into dt plus integration of 0 to t at into dt. It's integration of, I'm not writing the limit, I'm just v0 dt plus integration of at dt. Okay, just open the bracket and you can write as a separate ones, v0 dt plus at into dt. You have to write the, consider the limit also. Okay, then which will become v0 dt, v0 is a constant and dt will become t. So v0 will remain as it is and dt will become t in the limit of t0 t and 0. Whether 0 we don't want to consider, so which will become v0 into t. Okay, so x minus x0, here the x you have to apply the limit, then x minus x0. So x minus x0 will be is equal to v0 t plus, here you are having a t dt, isn't it? A t dt. So a is constant, a will remain as it is. But t dt will be, you have to take, if you are having the t is the term and you have to take the integration of the t. So integral t dt will be is equal to, so remember this one, okay, t square divided by 2. Okay, integration of one component with the d of that component means the dt, t dt, integral t dt will be is equal to t square divided by 2. If it is integral of x dx, then it will be x square divided by 2. Okay, so t square divided by 2. Okay, so it will become, you can see the x is equal to x0, that means x minus x0 is equal to v0 t plus half at square. Then x0 we are taking, here x minus x0 is there, isn't it? When we are applying the limit, it will become x minus x0, so which will be is equal to v0 t plus half at square. Then x0 we are taking here, so x will become, x will be is equal to x0 plus v0 t plus half at square. Here the thing that you have to remember is that t dt, integral t dt will become t square divided by 2. That you should remember. That's the first the initial time. So first time you are seeing or just dealing with the integration. So that identity, just to remember that one. Okay. Now let us come to the next one, that is the last kinematic equation. So as we know, here also we are considering that acceleration, instantaneous acceleration A is equal to dv by dt. But we are just multiplying and dividing that equation with a dx. So dx will cancel each other, it will not affect that equation, but we are still multiplying and dividing it with a dx. So which will become dv by dx into dx by dt. Okay, so dv by dx will remain as it is, and dx by dt is known as, we know that it is the equation for instantaneous velocity. Okay, so we have rewritten the dv by dt as is equal to dv by dx into dx by dt, because the ds will cancel each other, which will not affect that equation. Okay, isn't it? Now listen, the dv by dx will remain as it is. Let us write that one, dv by dx into this dx by dt is actually the v, instantaneous velocity, isn't it? So that will become v dv by dx. Okay, v dv by dx, and now you have to rewritten this one as v dv is equal to a dx. So a is equal to, you have written now v into dv by dx. Okay, so just cross multiplying the dx over here, then you will get v dv is equal to a dx, this one. Integrating both sides with the limit v0 and v, x0 and x, then v0 v dv will become, that is, now listen, here it is an important point is there, that is integration of v dv will become is equal to v square divided by 2. Applying the limit v0 to v, which will become, first of all you have to apply the value, the v over here, so that become v square divided by 2. Now you have to apply the v0 value. Okay, minus, first of all minus v0 square divided by 2. This is the way you have to apply the limits after the integration. Okay, I think now you understood this one. So which will be this v square 2 by 2 minus v0 square by 2 is v square minus v0 divided by 2, which will be now in the case of dx, right hand side the integration will be integral of x0 x a into dx. So a is constant, which will remain as it is. Integral of dx will become x, limit x and x0, a into x minus x0, isn't it? Okay, so now come to the equation. Okay, so now you are having on the left hand side, that is v square minus v0 square by 2 is equal to a into x minus x0. Okay, so that is v square is equal to, this means we are just cross multiplying, or we are multiplying both sides with the 2. Then v square minus v0 will be remain on the left hand side, and the right hand side 2 a into x minus x0 will be there. Okay, now you just it means on both sides if we are multiplying with the 2, which will become v square minus v0 square by 2 will cancel each other, isn't it? And which will be equal into 2 into a into x minus x0. Okay, now you have to take this v0 square to the right hand side, then v square will become, listen, v square will become v0 square plus 2a into x minus x0, where x minus x0 is actually the, x is the final point and x0 is the initial point. So that you can say that one as the displacement. Okay, delta x, or in another way, in another representation, the s also you can use the displacement. Okay, so then the kinematic equations, we have derived all the kinematic equations with the help of the calculus. So advantage of this method, if you are using the calculus method, you can use this one for the non-uniform acceleration also. Okay. Okay. Now let us come to the next question. That is the example 3.4. A ball is thrown vertically upward with a velocity of 20 meter per second raised to from the top of the multi-story building. The height of the point from where the ball is thrown is 25 meter. Okay, so a person is standing on the top of a multi-story building or a building, okay, of 25 meter height. He is throwing a ball upward with a velocity of 20 meter per second. You know that if you are throwing a ball upward after particular time, that means its velocity is decreasing. Okay, its motion is in the positive direction, but its velocity is decreasing, that is in the negative direction, and at a point which will become 0. Okay, at this point it will become 0. The velocity with which the body is moving upward will become 0, and it start coming down, or it fell down. So just consider, first of all, you just consider the motion between A and B. That means the upward motion. So initial velocity v0, it is actually 20 meter per second raised to minus 1, and the acceleration is actually the minus g, gravitational acceleration. Gravitational acceleration is actually acting downwards. Now the body is moving upward, so the acceleration should be taken as minus, okay, minus g, so which will be is equal to minus 10 meter second raised to minus 2 minus, okay, and the final velocity at point B, the final velocity will be 0. So these are the major values you are having now. And what it is asked, how high will the ball rise? The first question is that how high will the ball is rise. So you have to, first of all, you have to find the distance AB. Okay, the distance AB you have to find first of all. Okay, now come to the solution. So let us take the y-axis in the vertically upward direction with the 0 at the ground as shown in the figure. Okay, so whenever you are dealing with such questions, first of all you just try to draw the figure, then you will get a clear or crystal clear idea about that concept. Okay, so that's the best way to deal with such questions. So now you are having the values v0, a and v. v0 is the initial velocity, that is 20 meter per second raised to minus 1. A is the acceleration due to gravity, and it is acting downwards, the motion is upwards, so you have to take that one as minus value. So A is equal to minus g, which will be is equal to minus 10 meter second raised to minus 2, and v, the final velocity at the point B, is 0, because the body will become or body will stop at the point B, and if it return back. Okay, if the ball rises to a height y from the point of launch, then using the equation, okay, we are using the last kinematic equation, that is v square is equal to v0 square plus 2a into y minus y0, where y minus y0 is the displacement. So you just want to find out the y minus y0. You are having the v value, v0 value, and the acceleration also you are having. So you just want to substitute those values and you will get the v square. V is the final velocity, that is 0. 0 square will be 0 only. v0 square, that is initial velocity, which was 20 meter per second raised to, so v0 square 20 square, then 2 into a is minus 10 and y minus y0. We have to find out the value of y minus y0. Okay, the 20 square will be 400. 400 plus 2 into 10, that is 200. 400 minus, sorry, 400 minus 20, minus 20, 2 into 10, 2 into minus 10 will be minus 20 into y minus y0. Okay, so y minus y will obtain it one as a 400 is equal to minus 20 into, wait, 400 is equal to minus 20 into y minus y0. So now you don't want to consider that just want to find out the displacement. You don't want to find the direction. Okay, so you can neglect the minus value if you want. So y minus y0 will be is equal to 400 minus 400 divided by 20. So that will be 20 meters. Okay, sorry, minus value will be there. Actually, the 400 when you are taking on the left hand side, minus 400 will be there. So minus 400 divided by minus 20 will become 20 meter. Okay, I think now you understood. Okay, so actually 400, 0 is equal to 400 minus 20 y minus y0. So when you are taking the 400 on the left hand side, okay, when you are taking this 400 to the left hand side, it will become minus 400. Okay, now come to the next part of this question, that is, how long will it take? Will it be before the ball hits the ground? Okay, so how much time will it take to take by the ball to reach the ground? That is the next section of this question. So for that, it's explained very well in the textbook, in the example. Two methods you can use. First one, the v is equal to v0 plus 80, that equation. Otherwise, the second equation, that is displacement is equal to v0 t plus half a t square. So displacement you are having now, as well v0 a values, all values you are having now. So you just want to apply those values. Okay, the first method, as per the first method, the time required for the upward motion. First of all, you are finding the time required for the upward motion. So v is equal to v0 plus 80, where 0, the final velocity is 0, initial velocity is 20, and t1 you have to, or t value you have to find, isn't it? Upward motion find, you have to find the time for the upward motion. So substituting those values, and you will get the t as 2 seconds. Okay, you just do the calculations by step, then you will understand clearly. So directly you are just applying that values into the equation, and you are just rearranging the values and finding out the t value. That's all. Then now we have to find out the time required for the downward motion. So that is t2, taken as that one as t2. So for that one, we are using the y is equal to y0 plus v0 t plus half a t square. That equation you are using. Okay. Now, where we have y0 is equal to 45 meter. That means the entire displacement, that is 45 meters. So 20 meter is the height of the, 25 meter as per the, 25 meter is the height of the building, and 20 meter the ball raised up, isn't it? That we have found in the last question. The last section, the first section of the question, we have found that one is 20 meter is the height which was the ball has risen, isn't it? Now we have to substitute that value. That means the displacement, it is 45 meter, and y is equal to 0. So it means the final displacement, final point, it is 0. y0 is 45 meter. So the displacement will be 45 minus 0. 45 meters will be the displacement, and v0 is equal to 0. The initial velocity is 0, acceleration is minus 10. G is equal to, acceleration is equal to minus g, which is equal to minus 10 meters second raised to minus 2. So you have to substitute those values there in that equation. Then you will get the t2 value as 3 seconds. Just to solve that equation, then you will get it. Okay. Now the t1 and t upward motion, the time required for the upward motion and time required for the downward motion, both are there. Now we have to add up these to both the times. That means the entire time for the travel of the ball. So you will obtain the value as t1 plus t2, that is 2 seconds, plus the 3 seconds, that is 5 seconds. Now almost a similar method is there in the second method. Means a similar method it is. You just go through that one. Okay. We will discuss that in the coming section. The second method, you are just directly using the y is equal to y0 plus v0 t plus half at square equation, and you are finding out the time required directly. So just try that one. Okay then, thank you.